10.6. Now we go back to section 10.5. Okay. Okay, so let's look at rationalizing 81 on page 622. The square root of x plus 1 over the square root of x minus 1. We're asked to rationalize, in the book it says the numerator. So let's rationalize the numerator. How will I rationalize the numerator? Very good. With the conjugate of the numerator this time. Again, these are two of our special products. The top one is the difference of squares and the bottom one is something squared, a binomial squared. So tell me what, when you're ready, what I should write. The top. Very good. The bottom. Three terms. To the square root of x plus 1. Perfect. There is nothing we can do. Don't be tempted to simplify x and 1 or something. You can't touch anything. They're all terms, so we only simplify factors. Now, I don't want to forget about this. I think it's a very good idea to go over these problems. So on page 3 of the handout that I just gave you. So Matt is right. Let's work on these 4. So here it is. 6y squared minus y minus 1. Now, before I jump into the middle of chapter 6 like we're trying to do right now, I show my students a strategy. So there are several questions I have to ask myself before I say, oh, blah, blah, blah. But I'm going to skip that now. But normally when I'm trying to factor a polynomial like this one, here are my questions. And we're going to write them down together when we review this chapter. So check whether the polynomial you need to factor is presented in descending order. That would be my first thought, which it is. If not, you have to rearrange it. Check whether there is a greatest common factor in all terms. No, there is no greatest common factor in all terms. Check if polynomial's leading coefficient is negative. If it's negative, I have to do something. Then D. If the polynomial is, and we are here in trinomial, check whether one of the two trinomial special product is applicable. If not, blah, blah, blah. So there is a theory behind all this. So we're jumping in the middle because we want to look at these particular types of trinomials. So, but when we get to review, I'll give you the whole theory behind it. So it's in descending order, no greatest common factor, and I cannot do anything here. So I'm asking myself, how can I, or are there numbers whose product is this, which is negative 6? The sum never changes. In this case, it's negative 1. So are there two numbers whose product is negative 6 and whose sum is negative 1? Since the product is negative, the numbers have to have opposite signs. Otherwise, I will never get a product that is negative. So I need two numbers, one positive and one negative, such that when I multiply them, I get negative 6, and when I add them, I get negative 1. Very good. So these are the numbers that I will use to change this trinomial into a polynomial with 4 terms. So I can use grouping. So I have 6y squared plus 2y minus 3y minus 1. It's not important how you write them. The order is not important. I can write 2y minus 3y. You can write negative 3y plus 2y. You will get the same answer. If a polynomial is factorable, there is only one way to factor it. If you find the right way, I cannot find another way. That must be it. So now factoring by grouping. So from the first two, what do I factor out? Good. What is left in parentheses? What do I have to have coming out from the other two?
3y plus 1.
If I don't have 3y, and I know I have 3y plus 1, how do I know? Because I found the two numbers. Two numbers whose product is negative 6, and the same numbers whose product is the sum is negative 1. So this must come from the other two. As you see, I haven't even looked. I know it has to. And now I look, and I need a sign and a factor. So what is the sign? Negative. And the factor is? Right. We normally don't write it, but I would write it like that so everybody knows it's there. So now I have two terms. One term is here, and the other term is here. Both terms have a common factor that has to be pulled out, which is 3y plus 1. Something is left from the first term, which is
2y.
something is left from the second term, which is
Negative 1.
that's it. That's how we factor these trinomials with a leading coefficient that is not 1. Okay, back to the next one. Is 2x squared plus x plus 1. Yes, it's in descending order. I cannot factor out anything. And leading coefficient is not negative. So I go ahead and I try to find two numbers whose product is very good, this, and whose sum is perfect. Since the product is positive, both numbers have to have the same sign. Since the sum is positive, both have to have positive sign. So can I find two numbers whose product is 2 and whose sum is 1 and the numbers are both positive? No. So what do I conclude about this polynomial? Not. We're trying to factor it, so not factorable. Your book says prime. I'm really not in favor of that, but if you write prime, I'll have to accept it. The correct answer is not just not factorable. It's not factorable using integers. That's the correct answer. But that's what we mean, not factorable. Because if I can factor it with the square root of 3, that's not an integer. It's still factorable, but that's what we really mean. So this was not factorable. Next one, 4x squared minus 4x minus 15. It's in descending order. The leading coefficient is not 1. So I have no choice but to try to find two numbers whose product is and whose sum is. The sum is always the same. That's why we require the polynomial to be in descending order. Because otherwise I may find something that is not the product, right? Or not the sum. So what is the sum? Good. What is the product? Good. Since the product is negative, I'm looking for a positive and a negative. And when I add them, I have to get negative 4. So which one is more powerful? If I add them and I get negative 4, is the negative number more powerful or the positive number more powerful? Right, so that I can get a negative number. I owe you more than I gave you because the answer is negative. Good. So let's find a negative number and a positive number whose product is negative 60 and whose sum is negative 4. Negative 10 and 6, indeed. So what do I continue with? What is my next step? I rewrite the polynomial as 4x squared, then and then what do I do next? From the first two, good. What is left? If I don't get what from the other two?
2x minus 4.
I cannot continue. And I know that it has to be there. The reason I write it is because you may be tempted to write by mistake 2x plus 5, and that will mess up the whole thing. So that's why I write it first and then I factor. So sign and factor. Good. It's true, because 3 times 2x is 6x, and 3 times negative 5 is negative 15. So now the common factor gets pulled out. And in parentheses we have. Good. So the last one, I'll let you do it on your own, 1 minute. 5x squared minus 26x plus 5. Let's work on this one. Let me know if you need help. Yes, I'm sorry.
Very good. So that's it. And that's negative 26. The sum is here. Negative 26. The product, yes. The sum is always this number here. Negative 26. Since the product is positive, and the two numbers have the same sign. And the sum is negative. So we must be negative. So I need to find two numbers, two negative numbers, whose product is 25 and the sum is negative 26.
So did we get the idea with this better? We feel better? So product is 25, sum is negative 26. Both have to be negative because the product is positive. Both have to have the same sign. But since their sum is negative, they must be negative. So good. So then I have 5x squared minus x minus 25x plus 5. And I shouldn't cover it just yet. I need a new page. Now I can cover it. So from the first two, again, it doesn't matter how you write it. You can write it like this or like this. We'll get the same answer. So from the first two, x, 5x minus 1, 5x minus 1. And now I'm looking, and it's negative 5. So 5x minus 1 and x minus 5. If you have it as x minus 5 times 5x minus 1 is still the same thing. Why? 2 times 3 is 3 times 2. Multiplication is commutative. Good. So I think we're done with that. So back to 10.5 on page 622. Say it again. This one? No, this was from the handout. This one. So these 4 problems are from page 3. These problems right here. Okay, so back to 10.5. We looked at the rationalizing. Let's look at another one. Let's say number 20 on page 622 again, same thing. So the square root of 13a divided by 2b. We're asked to simplify this or do something. And here's the only thing I can do in the first step. I can only write the square root of 13a over the square root of 2b. And as you remember, there are specific requirements for radicals. And a radical is fully simplified. That's on our radicals handout. A radical expression is fully simplified if there are no negative exponents in the final answer. The radicals are simplified, that's what this means. And there are no radicals in the denominators. So this one has, they're all simplified, the square root of 2b, the square root of 13a, all simplified, but there is a radical in the denominator. So I didn't mean to write that, I have to write it again anyway. So over 2b, so I have to multiply it by, first of all, it has to be the square root. Yes, because I have 1 and 1 and I need a total of 2. So then the denominator is exactly what I want. What do I want the denominator to be? 2b. And the numerator I have to multiply. So the square root of, yes, they are real numbers. I'm allowed to do this. Everything here is real. Do you think we need more examples from rationalizing? Perfect, okay. Let's look at 23. In 23 we have the square root of 3x over 50. The first thing I have to perform is what? Yes, there is nothing I can simplify, so I have to rewrite it as the square root of 3x over the square root of 50. I realize that the only problem here is the radical in the denominator, but I have to simplify that radical. I'm not going to just go ahead and multiply and divide by the square root of 50. That's not a good idea. See here, I could have not simplified the square root of 2b in any way, shape, or form. But the square root of 50 has to be simplified. How do I simplify the square root of 50? Excellent. So then I continue simplifying. The denominator now is very clear. What? And now I know exactly which portion of the denominator needs to be rationalized. 5 does not need to be rationalized. 5 is rational already. So what will I multiply and divide by then? just the portion that needs to be rationalized. I'm not going to rationalize 5 because 5 is not irrational. It doesn't have a radical. 5 can stay in the denominator. The square root of 2 cannot stay in the denominator. So then the numerator is the square root of 6x indeed, and the denominator, perform this product first and then multiply by 5. That's it. Do not be tempted to simplify the 6 under a radical with a 10 outside of a radical. That will be a terrible mistake. Do we need more examples of rationalizing? Or can I go back to adding, subtracting? We're going to do this again on Tuesday. We're going to review again for the test. So can I go back to 10.4? Okay, I know I have 12 minutes, 13 minutes left. Okay, so 10.4. Okay, let's look at I feel like I should make one up. Let's look at 73. In 73, we have the square root of x minus 1 plus 5, everything squared. Again, this is not trivial. Remember, we have a lot to think about here. Remember, we have an agreement. And you'll tell me what you will write. Excellent. First term squared plus 2 times the first times the second plus the second term squared. Excellent. Thank you. The only thing I can do is just combine these two. There is nothing else. So I have x plus 10, the square root of x minus 1 plus 24. And no one can take this any further. This is it. Okay, so let's also look at -33. -2, the fourth root of x to the 7th plus 3, the fourth root of 16x to the 7th, and minus x, the fourth root of x to the 3rd. I think we did this problem. If you say yes, I'll choose another. It looks familiar.
I mean, they all kind of look alike.
That is true. From this section, I have to agree. Yes. Okay, let's work on this for a minute. Remember, you cannot combine them. The way they if you look at this carefully, you'll say, I will never be able to combine them. I don't know. We have to simplify each and every one of them. Which of these 3 radicals doesn't need anything?
The last one.
Exactly. Because the power is 3, the index is 4, this is done. But the other 2 need effort. What will you say about x to the 7th under the 4th root? Excellent. X to the 4th, x to the 3rd, the same thing. They are both the same. Very good. So now I have, you can write this step if you want to. If you feel more comfortable to write it, please do so. As negative 2, the 4th root of x to the 4th, and the 4th root of x to the 3rd, plus 3, the 4th root of 16, the 4th root of x to the 4th, times the 4th root of x to the 3rd, and finally minus x, the 4th root of x to the 3rd. Okay, so now this will come out of the radical, I mean. This will come out, this will come out. So how do I simplify the first radical? What is the simplified form of the first one? The 4th root of x to the 3rd. Excellent. What will be the simplified form of the second radical? What is the 4th root of 16? 2. But I have to multiply it by 3 in front. So plus the 4th root of x to the 3rd, and I copy the last one. Now remember what is important here. The radical has to be identical. Absolutely the same. The variable in front has to be the same, or variables have to be the same, and they have to have the same power. Yes, they do. Power 1, power 1, power 1. Therefore, I can say negative 2 plus 6 minus 1. And the answer will be 3x, the 4th root of x to the 3rd. Okay, so I'd like to find a perimeter of a trapezoid. I still have a couple of minutes. So in problem 45 on 616, we are given this. We're told this is 3, the square root of 3 inches. Oh, it's a right trapezoid. 2, the square root of 12, it doesn't matter, inches, and 2, the square root of 27 inches, and the square root of 12 inches. They're asking us to find the perimeter of this figure. How do I find the perimeter of this figure? Add them. Okay, very good. This is fully simplified. There is nothing I can do to it. Here, I will combine these first. So 3, the square root of 3, plus 3, the square root of 12, plus 2, the square root of 27. Now I will look at the second radical, I will look at the third radical, and I will split it. How? Yes. Very good. Again, if you want to write it again, please do so. If it's easier for you to identify or realize what you have to do, please write it one more time. So then, this is done. But this is multiplied by 3, 6, and this is multiplied by 2. Only now I can say yes. In order to be able to give an exact value or measure of the perimeter, I have to keep it with the square root. That is exact. If I put this in the graphing calculator, so 6 plus 6 plus 3 will be 15 inches. If I put this in the graphing calculator, it will give an approximation. But if you want to keep it exact, you have to say 15 the square root of 3. Okay. One more and I'll let you go. Let's say 25, last one. So we reviewed everything in chapter 7, chapter 10, except 1, 2, and 3, the first 3 sections. And we have to review again chapter 9. And then we'll go back and review everything again on Tuesday. Okay? So 25. So a cubed, the square root of 9ab cubed minus the square root of 25 a to the 7th b cubed and plus the square root of 16a to the 7th b to the 3rd. Let me read this again to you. A cubed times the square root of 9ab cubed minus the square root of 25 a to the 7th b to the 3rd plus the square root of 16 a to the 7th b to the 3rd. Yes, Becky? And b. Very good. So indeed the first radical is a cubed, square root of 9, square root of a, square root of b squared, and square root of b. Perfect. Minus the second one, the square root of 25 what do I do with a to the 7th? And the same thing with b, b squared and b. Plus the last one, square root of 16 same thing with the square root of a to the 7th, a to the 6th a, and then b squared and b. So, can anyone simplify the first radical for us? 3 from here, a cubed, b, and these two stay under the radical. Minus
5a cubed
5a cubed b, and these have to stay under the radical. And finally, plus 4a cubed b, and these have to stay. I have to make sure that everything is identical except the number in front. A cubed b in all of them, square root of ab in all of them. So the answer, simplified form, is 3 plus 4 minus 5. 2 a cubed b, the square root of ab. So I highly recommend